if a kid asked you what 5 plus 7 is equal to, and all you responded was it's equal to 12, they would probably be more confused than you would expect them to be, and just accept it and move on with their lives and not really even like internalize this fact very well. Problems like this are a lot harder than we kind of remember them to be. And understanding why they are true is very non-trivial. And a large part of that is because of the fact that we take our number system for granted, our base 10 number system. Kids that are learning how to do problems like this are still learning exactly how our number system works. And learning how to tie these two concepts together, addition and like the number system, is pretty crucial. So there are many strategies for approaching a problem like this. So you could represent it with a picture like this. How does this picture help us, right? So let's assume that we know how to count to 100, or whatever large number, and so we know that like every 10, every like whatever 10 means, every 10 objects we sort of like group things together, and that makes it 10. Okay, so we could take these 5 things over here and then combine them with 5 of the things over here. We would make a 10, and then we would have 2 left over, and so we have one group of 10, 2 left over, and so of course this would be equal to 12. All right, cool. That may or may not be enlightening. Let's get rid of that. Let's talk about how to do this in some other ways, other than using pictures. One way that you could do this is to try to make a 10. So 5 and 7, you could pull out 3 from this 5, because 3 and 7 is going to make a 10. So this 5 is really 2 plus 3, and then plus 7. And then you could combine the 3 with the 7, and then this is going to make a 10. So this is going to be 2 plus 10, which is 12. So we're making a 10 there. You could do this in the other way. You could say that 7 is made up of 5 and 2. So this is equal to 5 plus 5 plus 2, which is 10 plus 2, or 12. That's another way of doing that. You could think of this in terms of like doubles. So 5 plus 7, so 5 is 1 less than 6, and 7 is 1 more than 6. So you could think of it as like taking, borrowing 1 from the 7, putting it with the 5. And so this problem really becomes the same as 6 plus 6. And if you know your doubles, this would be equal to 12. Okay, so if a kid knows their doubles, then that's really helpful too. Because if they know like what all their doubles are, like 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5, 6 plus 6, that's really helpful. By the way, if they know their doubles, they can sort of use this approach as well. Because if they know what 5 plus 5 is, then this is like 5 plus 5, but like 2 more. So 5 plus 5, and then add another 2. 5 and 5 makes 10, and then go count up from there. So 5 plus 5, then count up by 2. That'll get you your answer. Here's the same problem, but in a different base. So 5 base 9 plus 7 base 9. What is this equal to? Okay, off the top of your head, you probably don't know the answer. If I just told you that it's 13, you'd be like, great, what that, cool. Makes no sense why that would necessarily be true, but guess what? It's 13. So let's think about why that would be true. So 5 plus 7, if we're in base 9, remember we're trying to group things in groups of 9s. So if I want to take a picture-based approach here, I want to make a group of 9s. So let's do that. Let's just get rid of that. So we have 5 over here, and then we have 4 over here, and now all of a sudden, this right here is a group of 9. So we have one group of 9, and then we have 3 singletons left over. So this is equal to one group of 9 plus 3 singletons. So this is like 13 base 9. Okay, let's think about this in some other ways. We could also do some of the same strategies that we talked about before. Okay, so instead of trying to make a 10, let's try to make a 9, right? Because the whole point of making a 10 is because that's going to like increase our place value. So let's try to make a 9. So 5 plus 7, if I want to make a 9, so I can take 2 away from this 5 and combine it with the 7 to make a 9. So this is equal to 3 plus 2 plus 7. Now this is going to make a 9, which you would, in base 9, write that as 1, 0, base 9, because you have one group of 9. So this is 13, base 9. You could do this the other way as well. You could do this as 5 base 9 plus take 4 away from the 7. This is equal to 5 plus 4 plus 3. And this is 1, 0, base 9. So this makes 13 base 9. What else could we do? So in the previous one, if we know our doubles, then knowing our doubles is going to help here. So 5 base 9 plus 7 base 9 is the same as 6 base 9 plus 6 base 9. Okay, and so knowing your doubles in base 9, you probably don't know your doubles in base 9, but if you did, you would know that this is equal to 13 base 9. So knowing your doubles, how would you learn your doubles? Well, you would kind of think, so it goes up 2, 4, 6, 8, and then goes 1, 0, base 9, and then the next one would be 11 base 9, and then the next one would be 13 base 9, and then the next double would be 15 base 9. So this is 1 plus 1, this is 2 plus 2, this is 3 plus 3, 4 plus 4, 5 plus 5, 6 plus 6, base 9. So if you knew your doubles, then you would know that 6 plus 6 base 9 is equal to 13 base 9, right? Of course, we don't know our different base doubles. This is really just a foundational, like, if you did know this, this would help you do a lot of mental math a lot more quickly. Okay, so let's say that we were trying to fill out an addition table using base 6. So let's do this whole thing in base 6. So doing this, first thing that you should observe is that you really only have to do half the table. So let's get rid of this whole top half, because if you do 2 plus 3 base 6, that's the same as 3 plus 2 base 6. So if you know one half of the table, then you should know the other half of the table. Adding 0 to everything is going to be really simple, because 0 plus anything is going to just give you the same number. Adding 1, counting on is a very important strategy. So if you know how to count in base 6, which would go 0, 1, 2, 3, 4, 5, 10 base 6, 11 base 6, 12 base 6, 13, 14, 15, 20 base 6. If you know how to count in base 6, then that is really helpful, because then you can just sort of count on here. So 1, if I add 1, I'm just going to be counting on. 1 plus 1 is equal to 2. 1 plus 2 is equal to 3. 3 plus 1 is equal to 4. Just count on. 4 plus 1, 5. And then 5, count on. The next thing that I would get to would be 10 base 6, right? Because in our base 10 system, 1 plus 5 is equal to 6. That's one group of 6, so that we would write that as 10 base 6. If we can count on by 2's, that's also helpful. 2 plus 2, get to 4. 3, 4, 5. 4, 5, 6, but 6 is really 10. 4, 5, 10, right? 5, 10, 11. So we would get there. You could count on by 3's, but that starts getting a little bit more difficult. If you wanted to do 3 plus 3, well, this is another place where knowing your doubles would be helpful. So if you knew your doubles, so 0 plus 0, 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5. Knowing the doubles is really going to be helpful. Oops, that's not right. So this would be a 10. 4 plus 4, that would be a 12. 5 plus 5, that would be a 14. 6 plus 6 would be, that would really be like 10 plus 10 would be 20. Base 6. Right, and so on. 4 plus 3, we could do this one in a similar way to what we were doing before. So base 6. Could try to make a 6 out of this. So this is like 4 plus 2 plus 1. So this would be 10 plus 11, or 11 base 6. If I wanted to do 3 base 6 plus 5 base 6. So maybe I know my doubles. I can know if I knew that 3 plus 3 makes 10 base 6, then this is like 3 plus 3 plus another 2. So then 10 plus another 2 would be 12 base 6. And let's say I wanted to do 5 plus 4 base 6. So this I could, so 5 plus 1 would make 6, and then plus another 3. So I would have one group of 6 here, and then 3 singletons left over. So that would be 13. Okay. That's how we would be able to fill out this base 6 addition table.